Hi, guys. We're going to talk about rotations today. And remember that rotations is just a fancy word for a transformation that is a turn. Okay, so we're going to be turning figures today. Okay, so we have some words for you to know. I'm going to shorten up some of these definitions for you. The center of rotation is, well, actually, those of you who are watching the video, I'll shorten it for the kids in class. You can just pause it and write these down. A center of rotation is the point that the figure turns about. So in this picture here, like you see this point P, they're all turning around it. It's like it's the center. The angle of rotation is where if you take the point and then you draw it to the center and to the point where it is going to, that is the angle that it makes. So from the pre-image or the original to the new guy, the angle of rotation is the angle that it would change. Counterclockwise, if you have hands on a clock, I don't know why I did it this way, but counterclockwise is to the left, clockwise would be to the right. And strangely enough, we assume things will be counterclockwise unless it says differently. Okay, rotation is just a turn. It will change the orientation a little bit of the way that it looks. It won't be a straight slide where you can definitely tell because everything will kind of turn with it. And a revolution is like a full circle. If it's a full circle, that would be the revolution. So a rotation we said is a turn, and a lot of things turn. You know, lots of things that turn. So give some things that you turn, like this triangle is turning around this center and a bicycle wheel. So what other things turn? A steering wheel can turn. Oh, a merry-go-round, a Ferris wheel. What else? A spinner and a board game. What else can turn? I'm gonna say wheels, a lot of different wheels. Gears can turn. Okay, so come up with four and write them down in your notes. Okay, so this is pretty cool. It'll help you see the rotations a little bit better. So we're going to go to a screen. It's not going to be just like this, but it'll show you what these different types of rotations look like. Okay, so let me go here to 0 first. There you go. Okay. So if it doesn't turn at all, the two the two triangles are right on top of each other. Okay, I'm going to actually move the center so that it's at 0, 0. This is going to be the center and how it moves. So now look, if I rotate it 90 degrees, there it is. Because if I go from the old point here to the new point here, that would be 90 degrees. Now, if I move the center of rotation, it will make it look different because look, it doesn't have as far to turn. But when I moved it here, it just made the turn a little bit bigger. Okay. So what's a 180 look like? 180 is almost like a, can't get it quite there. It's a little touchy little thing. It will go from the old point straight through to the new point. It makes a straight line or 180. And then what happens is when you get to 360, whoop, you get right back to where you started. That's the full revolution. So it's just a way for you to see what these different rotations look like as it goes around. Okay, so we said clockwise, go in the ways of the clock, and that would be to the right. Counterclockwise goes to the left. So if you're looking at these shapes, the orange one, if it went to the purple, that's clockwise, but if it went to the green, that's counterclockwise. And we usually assume counterclockwise unless they tell us something different. The point of the center of rotation is important because it will tell us how far to get to the 90. If I had the point of rotation here, for it to go 90, it would have to be over here more because it has to make the 90 degree when you go from the old point to the center to the new point. So they rotated 90 degrees here because from the old point A to the center to the new point, that would be 90 degrees. So it's a 90-degree rotation. So what is P called here? If they went from B to P to B prime, you can tell that it rotated. And again, it looks like 90 degrees, but it's called the center of rotation. So a revolution is a full circle. So if you go all the way around, you come back to where you start. That is a full revolution of 360 degrees. And if you have a full revolution, it will take the figure and it will put it right back on top of itself. And that's how you can tell that they are congruent because it would be the exact same shape. So if I take this triangle ABC and I rotate it 360 degrees around point P, where will the image of B be? Where would B prime be? Well, since it's 360 degrees, B prime will be right back where it started. So B prime would be in the same place as B is right now, and that point is 3, 1. Now let's try this guy. We have a figure and we're going to complete the statement. Where is the center of rotation? Well, it looks like C is the center. So point C is the center. And it's a 90-degree rotation, but which way did we go? Well, let's start at E, then you go to C, and you go to E prime. Well, there's the 90 degrees. This is the original, and it went here. What direction is that? That is actually clockwise. Okay, you didn't just have to use E. You could have used any point. H to C to H prime. There's 90 degrees as well. That one's pretty easy to see. F to C to F prime. It's a little harder, but that's also 90 degrees. So all the points went 90 degrees if you connect it to that center. So 90-degree rotation is what we call a quarter rotation, or 1/4 of a revolution of a whole turn. This is a half turn, 3/4 of a turn, and a full turn. These are all examples. So if this is the original, we'll go with L since it's the easiest to see. If L goes to here and to P, there's a 90 degree. So it's a quarter of a revolution. When it does the half revolution, L would go to the center, which would go to S. That's 180. Straight line, and that is a half revolution. 3/4 would be, it's hard to do 270 rotation because it's more than 180. So what it is, it's like 180 and then 90 more. So right here, or you can think of it as 360 minus 90, but 270 is kind of a tricky idea for kids because those degrees bigger than 180. And then when it gets to 360, it's right back to where it starts. So let's talk about that angle again. You have that angle. So you start at your original, your pre-image. You go to the center, which we'll use the origin right here. You go to A prime, and that is your angle of rotation. So this one is a 45-degree angle. It's not 90, it's like half of 90. So when they move it just a little, you can tell. You didn't just have to use A and A prime. You could have used B to B to B prime, and that because 45 as well. You also could have used C, but that one's the hardest by far to tell because it's not on the axis. It's usually easier to use one that's right on the axis if you can to help you figure out what the degree measure is. So let's try this guy. We have a green triangle, which is here. We're going to rotate it to get to the blue triangle. So definitely it's going from green to blue. That is counterclockwise. But let's see if we can figure out the degree. Let's just connect some dots. So P will go to the center, and where would P end up? P would end up where S is. What degree does that look like to you? It looks like 90 degrees to me. That will be a 90-degree rotation. How about QRS? QRS is this kind of bluish one here. How am I going to get to JKL, which is all the way over there? Well, it looks like I'm going from here to here. It looks like clockwise. That's not clockwise. You guys are like, Miss Bruno, from here to here, that's not the way the clock hands move. The clock hand moves this. It is counterclockwise. And I'm going QRS to JKL. So S would match up with the tippy top over here at L. And look what that is. That's a straight line. So that's a 180 degrees. It is easier when they have the prime marks. They don't have it here, but you can kind of tell the short side and the long side and the tippy top. All right, let's try this rectangle one. Find the direction and angle of rotation for this transformation. Okay, so which one is the original? Well, it's the orange one. We know that because there's no prime marks. So from here to here, it looks like I'm going to the right, which is clockwise. So I'm going to cross out these counterclockwise ones because I think I'm going clockwise. Now let's see if we can figure out the angle. Well, here's K. go to the center, and go to K prime. Does that look like 90 degrees to you? It doesn't to me, so it must be 45 degrees. If you want to double check with another point, you can. How about L? L to the center to L prime. Doesn't look like 90, looks like 45. Okay, if it's a 180 rotation, when you connect it, it will make a straight line. So A to the dot to A prime is a straight line of 180, as is B to the center to B prime. Okay, it really kind of looks like almost a double reflection. If you would reflect here, and that's something that you will see, it kind of does look that way. And it doesn't matter if you go clockwise or counterclockwise, you won't be able to tell because it's exactly half of a circle. All right, let's try this one. We are going to figure out what is the best statement. B, C, D, E. Here it is. It's orange. If I rotate it 180 degrees, will I get to J, K, L, M? Well, maybe. Let's see. B could go to here, could go to here. That looks all right. C could go to here, which would go to K. That's okay. D could go to here, which will go to L. Yeah, it does look like I could get to JKLM from 180. And it doesn't matter if it was counterclockwise or clockwise because you cannot tell I'm 180 degrees. How about BCDE to PQRS? Is that 180 degrees? Well, no, because look, if I go from B to here, I can't get to any of them by making a straight line, right? It's always an angle of some sort. So that's not correct. So the top one so far, JKLM could go to BCDE. That's true because we just talked about it for the first one, but can JKLM go to BCDE a different direction? Can it go clockwise and counterclockwise? The answer is yes, because you can go clockwise or counterclockwise 180 degrees and it will look the same. Okay, just to wrap things up, because it's a pretty quick lesson, a rotation is a turn. You need to know the center. And if you take the pre-image to the image and touch the center, it will give you the angle of rotation. And we can go clockwise or counterclockwise. All right, so that's it for today.